All right, how's everybody doing out there in Math Magic Land? This is Miss Muscarella coming at you, and we're going to take a look at Super FRQ number 5. Now in this video, we're going to take a look more specifically at Super FRQ5a. Now, we've got this figure above that's the graph of piecewise functions, 2 semicircles and 2 line segments from -5 to 5. And our function g is going to be defined by this integral from 1 to x of f of t dt. When they're asking us to find g of 5, we're basically, what they want us to do is go ahead and start at 1, and we're going to roll our function out all the way here to 5 and see what the cumulative area is for that. All right, so when we do that, we'll just have to very simply use our geometry knowledge to help us with that. So I'm going to call this triangle up here 1, and this triangle down here number 2. Now the triangle for 1, so we're going to label that area of 1. That's going to be 1/2. Now the base on this is 1, 2, 3, so the base is 3, and the height is 2. Calculating that, 3 times 2 is 6, and I'm going to leave this as 6 over 2 for right now. I'm not going to bother simplifying it, and you'll see why in a little bit. Now the area for our second triangle is going to be 1/2, and then the area or the base and the height are both 1 on these, so when we combine that, we're just going to get 1/2. So the area for the first triangle is 6 over 2, or 3 if you reduce that, and then the area for the second one is 1/2. So when we're finding g of 5, what we want to do, g of 5 is going to be the integral from 1 to 5, and that goes in a left to right direction of f of t dt. Now simply put, that first triangle, because it was above the x-axis and I'm going in a right to left direction, or I'm sorry, left to right direction for my limits of integration, I'm just going to calculate that to be 6 over 2. And then the second triangle, this is one I have to be careful of because that's below the x-axis. I'm going to subtract that, and area of 1/2. When you do all of your cleaning up on that, you will just get 5 over 2 for your solution. So g of 5 has a value of 5 over 2. Now let's take a look at the second piece of that. And on the second one, now we're going to find g of -5. Now this one's going to be slightly different because we have our 2 semicircles here. And our 2 semicircles, we're going to start here at 1, and then we're going to we're going to roll our function out to the left. So we're starting on the right and we're moving to the left. First, let's just calculate our areas of each one of our semicircles. So I'm going to call this semicircle 3 and this area over here 4. So when I go to find the area of my semicircle, which is denoted by area 4, that's just going to be 1/2 and then pi r squared. So I'm just going to put the pi right there on top. And our radius for the smaller semicircle is just 1. So that whole thing is just going to give us a value of pi over 2. So the area of semicircle represented by 4 is just pi over 2. Now we're going to go down here. For the area of the semicircle represented by 3, I'm going to have, now this radius is what, 1, 2. So I'm going to have pi over 2 times 2 squared. 2 squared is 4, so that is going to just be 4 pi over 2. And I'm not going to reduce that yet. You'll see why, because it'll just make things a little bit easier. So when I go to determine the value of g of -5, g of -5 is going to be the integral from 1 to -5 of f of t dt. Now when we roll that out, notice our lower limit of integration is 1 and our upper limit of integration is -5. So one approach you could do with this is flip that and make that the integral from the opposite of the integral from -5 to 1 of f of t dt. And if you do it that way, you're just going to put a negative sign out in front and then do all your calculating. Now for the semicircle represented by area 3, that area is below the x-axis, so I'd need to put a negative sign with that. So I'd have negative 4 pi over 2. And then the area of semicircle number 4, that's above the x-axis, so I would just keep that as pi over 2 and add that. Combining those two, I'll get negative 3 pi's over 2. And then I have the opposite of that, which of course would simplify all the way down to 3 pi over 2. Now for the purposes of the AP exam, you can walk away right here on the g of -5 because your answer is numerical, so you're good. And the same thing in the first part. You can actually walk away right there where you have 6/2 minus 1/2. So you don't have to simplify. So when you're working through that, we just want to see the setup and then we want to see the calculations that would lead to a numerical answer. So as long as you show your setup and then you show your answer, that's numerical, you will be fine and you will earn all of your points for an AP problem. All right, that's it for this video. Come on back and check out the rest of the videos for this problem. Thanks so much. Have a great day. Peace out.